So the previous program that we made could do the analysis that we're after, the semi-automatic mouse position or the beetle position analysis that we were after. It was quite a simple version because a lot of the stuff that we did was done through the command prompt. Here is a version that I've prepared earlier where I've created a GUI using Qt Designer and PyQt5. And so it's a little bit more in depth, a little bit more detailed than the previous program. However, the main functionality is it's retained. So let's have a quick look at that other program, or the GUI version that I've created. So here it is. We've got a standard single widget, single widget main window here. We've got some file and we've got a help here. So we've got some about how we've created the program, reporting the bug for the program, and how to get, I've written a help file as well. And then we can exit and quit out of that. So that's a fairly straightforward navigation. It's very familiar for Windows users. So let's select the video file. So the one that we wanted was Ringo trial. And as we can see here, this is the file that we're currently going to work on. And from that, we've pulled out the width and the height of the video frame. We've also got the frames per second and the length. So if you remember from the previous program, we did all this and we placed that information onto the command prompt. I've got it here under the video file. What we can do next is we can set up the analysis. So what time did we want to start? What's the interval, and how long do we want to do the analysis for? Now, if the user tries to analyze 300 seconds of data, and you notice here the length of the video file is less than 300, when we go to update and store this information, we'll get the error. So the error is, look, your analysis time is too long. Please go back and check it up. So here we've got some error messaging here. So let's say they only want, say, 50 seconds of data. So we'll start at 1 second, we end at 51 seconds, we have 25 frames, because remember it's 25 frames per second, and we will have 50 measurements remaining because we've made no measurements. Now for this particular experiment, it's going to be for a visual cliff task. And so what we could do is essentially define some areas of the arena. So if we wanted to define where the cliff is, we can click here. So remember, this is the video file, the first frame of the video file. So this should be quite familiar to us. There's Ringo there in the middle. And we can click, okay, if there is of interest, we've clicked there, and as we can see, we've stored that XY position there. Hit Q, close that down. We can then define the lower area here, and as you can see here, we close that down. We can update that anywhere we want, okay? We can update that. The other thing that we can do is we can define the area. So top left, okay, we can get the top right of the arena, the bottom right of the arena. So what we're using this information for on the bottom left down here, we're using this because we know just how wide. For instance, we know that this is 30 centimeters across here, and this is 30 centimeters from here to here. So now we can convert between the pixels and the distance. Because if we wanted to measure the total distance traveled, then we would be able to use that conversion based on the XY coordinates of the arena itself. Last thing, we want to save this data, so we'll save this. We could make up our own file, so I'll call this test file.csv. It's going to save it as a CSV, and we can navigate to where we want that to be saved. I'm just saving it into this cliff task folder. So this is it. We've set everything up. Okay, we can save all of these positions. So we've saved that into this file here. But if we want to start the analysis, we'll click the start button, and what we get, it's gone onto this screen. what we get here, this is the first frame. It's got the current video time, and we're taking measurement 0 of 50. And here is the forwards, backwards, and quit. So this is exactly what we showed before. We then click on the mouse's position, and we can see here at the first second the mouse was here, and then we can go forward, pushing the F button and doing the analysis. So 6, 7, 8, 9, remember Beetle got stuck in the middle there, 10, 11. Okay, so we'll stop there. So let's say that was all of our measurements. If we hit Q to quit, we automatically save that data again. So all of this information and all of the cliff location and the arena coordinates, they've all been saved. So we can go OK, and we can go to our file and we can find that. So let me I've just gone onto this screen. I won't bring that across, I'll just open up the test file. Programming, Python, click task, and it was test file. So it's opening up here. I'll bring it across. 3, 2, 1, there it is. And so here we can see we've got the upper cliff XY coordinates, the lower cliff, the XY positions of the top left, top right. So we've saved this as a CSV file, and then we've got the time here, the X position, and the Y position. And that corresponds exactly to what we have here. So there we go. We can clear everything out, and we can get the next video file if we wanted to do a different video file. For instance, we could do something like this. For instance, so here we can get the coordinates for a different video. Okay, so that would be an experimental video that we have. All right, and we can close this down. As you can see, we've got all the tooltips down here as well. So if the user needs any advice or help on what's going on, we've got some tooltips as well as some status tips. So look down here for the bottom, and it should update. So we've got a program here using a GUI, very simple GUI that will control the program. We quit out of that, and we can return control back to the user. That's it. Semi-automatic detection of a mouse or a beetle or anything using OpenCV, Python 3 and PyQt5 using the Qt designer to do a bulk of the heavy lifting in making the GUI elements. I'll leave it there.